this is question 1 on the test. This is question 2 on the test. For sure, this is 1 question on the test. So I don't know if I'm going to try and give you a test that's worth 110, so you can boost your test grades a little bit. And we already know the extra credit is what? A secant line, right? With probably a radical function, a square root function. Nice. So what's the mother here? What's the mother function?
You're not sharing your screen.
Oh, sorry. Sometimes Robert is pretty dumb. There it is. What's the mother function?
Cosine of x.
Nice. Nice, Yvonne. Thank you. So I would like to be able to get a quick sketch of cos. I need my quarter steps. I need my max of 1, my min of -1. I'm really looking at this rectangle, right? With my amplitude up, my amplitude down, or a diameter, the midline, and then of course my quarter steps, right? And I know cosine starts at 1, goes down to 0, down to -1, back to 0, back to 1. And there's the graph of my mother function. I have a reflection, right? I have a reflection from this negative out front, right? So negative cos of x is the daughter, right? So it looks like I'm going to have a daughter, and then a granddaughter, and then a great-granddaughter, and a great-great-great-granddaughter, right? If I'm taking in all of these pieces, that's 1, 2, 3, 4. So great-great-granddaughter we're going to get to. So what happens with this is I'm just taking all my positive y's and making them negatives. So I just kind of get an upside down of this cosine curve. Now I've got a change in amplitude. I'm going to turn up the volume to 2, right? When I turn up the volume, like if you think about a speaker, when you turn up the volume, the speaker kind of stretches out a little bit, right? And it's quiet. The speaker, the actual skin on that speaker is in its normal state. And if you turn up the volume, it kind of like, right? So it's making the circle bigger. So I have my amplitude of A equals 2. So what am I going to do? I'm taking... Now, I'm always going, right, so for my first curve, I started with the mother, and then the next curve, I started with the daughter. Now I'm going to go to the granddaughter. So I already know I've got to stretch out my height of my circle to 2, right? So I've got this new kind of rectangle happening here, right, with my quarter steps and all of that. So I'm going down to -2 to 0, sorry, to positive, yep, to 0 to back to -2. And there's my y equals -2 cos of x. How are we doing here? We okay? Following? Nice. 3, 6, 9, 12, 15. Oh, I'm only missing... I'm missing Abraham? Is that it? Let me count again. 3, 6, 9, 12, 14. Now I'm missing 2 students. Abraham and somebody else. Okay, my next one is the frequency, right? So B equals 3. And it's important that I factor this. The way I'm teaching it is I'm asking you to factor out that B value first. And so I get x minus pi over 6. It's easy to see that factoring if you distribute it back, right? If I distribute back that 3, you see I'm going to get 3x minus pi over 2, right? So I don't know how you're going to teach it to yourself, but it should have already been taught to you how to factor out a 3 from a fraction, right? So if you factor out a 3 from the numerator, you have to multiply the denominator by 3, right? But once again, that thought is not as easy as distribute that back and see that it's true. That's what you get. Now the book teaches it to you without factoring. I think it's easier with the factoring. So I get a frequency of 3, which means in my normal cosine curve, I would see it happen 3 times. So in the period of 2 pi, I'm going to see this cosine curve happening 3 times, right? So what do I have to do at this point? I have to think about that period, which is 2 pi over 3, and I have to think of a quarter step, right, which is 2 pi over 3 divided by 4. So that's 2 pi over 12, or pi over 6. So I have a quarter step of pi over 6. And so, of course, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, right? So I'm going to get the whole cosine curve done from 0 to 4 pi over 6. So what I'm gonna do is I'm gonna scale everything to pi over 6's, and I'm going to go all the way to 12 pi over 6, just so you can see this. So 1 pi over 6, 2, 3, 4 pi over 6, 5, 6, 7 pi over 6, 8, 9, 10 pi over 6. What did I do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. I don't like the way I scaled it, but it doesn't matter. Oh yeah, I wanted to go to 8 pi over 6. Sorry. 9, 10. What did I do wrong? 1, 2, 3, 4. Oops. 1, 2. Oh. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It does all right. I'm just going to... I know 12 pi over 6 is 2 pi, right? And I should probably have my 6 pi over 6. That's where I want it. Sorry. I'm just screwing things up right now. It's okay, though. I put those other things in a second so you can see it. Anyway, I need a height of 2. And the min to negative 2. And I see that I'm going to start, that's what it is. I'm going to start at 0 and end at 2 pi over 3, right, which is here. And so I want that box, right? I want that box. I want to see my quarter steps, right? And now my cosine curve. I know I probably screwed a couple of you up a little bit there, but you'll get used to it here. So this is y equals minus 2 cos of 3x. Now I want to let you see what, again, this frequency means. It means when I had originally done the cosine curve at 2 pi, right? So when I had originally done the cosine curve at 2 pi, right, all the way to 2 pi, and I need quarter steps here. I have 1 to 12, right? So I need every 3, right? I need every 3. 1, 2, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes. So every 3. So I'm trying to highlight this thing, this original cosine curve in yellow. There's my original period with the original amplitude. And then every 3 tick marks, I get a quarter step. Let me put those in red. Every 3 tick marks, I get a quarter step. Good. So look at this original cosine curve, right? Here, then here. Oops, sorry. Yes. here, then here, then here, then here, then here. Here's that original cosine curve, right? That red one is y equals minus 2 cos of x. And look at this purple curve. You see it's finished a lot earlier. In fact, I'll get 3 of them and that's what the frequency 3 means. What would normally take, our regular period gets completed in a third of the time. So there's 3 cosine curves happening in that same period. Okay, finally ready for the final graph here. And I'll say to you that until I put the phase shift in, it's nice to superimpose all of these things on each other. But once I put the phase shift in, it doesn't make a lot of sense to superimpose the final thing over the original mother. Okay? So, kind of starting fresh again. Y equals negative 2 cos of 3 times x minus pi over 6. I had b is 3, so the period is 2 pi over 3. So the quarter step, I can almost spell. The quarter step is pi over 6, right? I got 2 pi over 3 divided by 4, which was pi over 6. And my start is at pi over 6. So what I want to do now is I know I'm starting at pi over 6. I'm shifting my whole rectangle to the right. And now I want to think about how do I get the quarter steps. So I want to do take my first step. And my first step is to go from pi over 6, the start, right? This is the start plus a quarter step. I get pi over 6 plus pi over 6, which is 2 pi over 6. And now I can see I've got a 1 pi over 6, then a 2 pi over 6, and what's next? 3 pi over 6, 4 pi over 6, 5 pi over 6. So my start and steps are 1 pi over 6, 2 pi over 6, 3 pi over 6, and I don't reduce these, 4 pi over 6, 5 pi over 6 is where I'm ending. If you take that last step and subtract the start, you get the distance of the whole trip, right? So I could see that the period is going to come from 5 pi over 6, that's the end, minus the start, right? And that's 4 pi over 6, which is 2 pi over 3, which we knew was the period anyway. All right, I'm ready for my picture. I know I need pi over 6's. I know I have to start at the 1 and end at the 5. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This one was a little easier than what I did on Wednesday, so make sure you watch that video. And I know I need a scale up to 2 and down to negative 2. But remember, this is my start and this is my end. So my rectangle is here, my quarter steps are here, and I know the shape of my cosine curve. And there it is. And the book asks you to label all of the main points, but I don't care. What do you think? That's worthy of a test question for sure, right? No one can see it, so that if you want to ask something without being called out, or you can do that. Cool, we ready for new stuff? So you really have to be, like, when you do your formula sheet, you have to be saying, well, what does Robert want to see here, right? Or how can I use the calculator to verify things? Or, you know, how do I find this? What do I have to show on the paper, right? So I get full credit. And all I have to do is do everything the way I do it. I mean, you know, there are exceptions, right? So I think we're ready to move on. Everybody's on mute today, so that's fine. I'm taking a look at the textbook here real quick and looking at starting chapter 7. Now, the stuff that we're going to start here with chapter 7, I think it's fun, and that's in quotes. I think it's easy. I wouldn't, you know, condemn you for not even looking at this stuff until the test is over. But once the test is over, you got to get running with it. Okay? I don't think it will screw you up. So meaning if you're ready for the test, start working on this chapter 7 material, please. And if I want to just look at chapter 7 in general here, you can see, and we're doing up to 7.6 here. 7.1 and 7.2 are inverse functions, inverse trigs. So you did those in 098. We're going to take them to a little bit of a higher level as we work on them here in 165. Then trig equations. I kind of sort of need the inverses to do those. So I'm jumping right to 7.4. I don't need any of that stuff to do 7.4, which is trig identities. And then basically trig identities and trig equations continues through 7.5 and through 7.6. Sum and difference formula, double angle and half angle formulas. So I think really 7.4 is the easiest section here, so that's why I'm doing this one before the test. And I will probably start trig equations tomorrow. Monday. And Wednesday we review. But Monday, feel free to give me some questions to do, please, for the test. Let's take a look at our problems for... Now, there's going to be no homework for 7.4 in MathXL because it doesn't make sense. What we're going to be doing... are things called proving trig identities. So 7.4 is all about proving trig identities. The book calls it establishing a trig identity. Same thing. You're just going to verify that it's true. So you see here on this page, and if you can take a quick picture of it, I like problems 21 to, I'd say probably 95. Yeah, probably. In reality, probably 39, around 39 to 93 is more likely where your work will come from. Okay, so you should do all of them. I did all of them. And you're actually you almost can double your problems, because what we're going to be doing is starting on one side and trying to get it to say what's on the right side. So I could start on the left side and get the right side, or I could start on the right side and then get the left side. So I almost doubled the number of problems I could try here. And in the back of the book, it just says proof. It says one word. It says proof, or did you get it? Because it's obvious when you get it. When you get the left side to match the right side, you got it. So there's no way to do these on MathXL. There's no solution needed, because either you get it or you don't get it, right? And so it's just going to be about practicing it. And this is going to really amplify your weakness in fractions, factoring, algebra. Okay, so this is good for you. And I will say to you this: calculus is easy, but the algebra in calculus is not easy. It's almost like a third level. Like you had algebra 1 and algebra 2 in high school. It's almost like it's an algebra 3 now, because the algebra is so complicated. Okay, and there's no way around it. You have to be able to do it. So we should be able to get a picture of these two pages. This is from section 7.4. And what's interesting is as we do 7.5 and 7.6, there's two more pages like this of more identities. So once I give you sum and difference formulas and then double angle formulas and then half angle formulas, I get more and more trig identities to do. So we'll be doing these for a long time, and they happen all through the calculus sequence. Okay. Nice. I need to go over my list of identities to date and some brand new identities. Well, they're maybe not that brand new, but and then we can start doing these problems. So I want to talk about my trig identities first. So we have the OGs, right? Where I'm dealing with theta and opposite and adjacent and hypotenuse, right? So I'm not going to list all of these unless they're brand new. But obviously we have sine of theta equals opposite over hypotenuse, right? Cos of theta, etc. So I'm not going to keep going on with this. You know all of these, right? So these are the old school, the original, right? I'll just say original. Or maybe the origin, the mother, or whatever, right? The original way we're defining these trigs. We had trigs in terms of trigs. We really only have two there. Tan of theta is sine of theta over cos of theta. And cotangent of theta is cos of theta over sine of theta. And now so we've got two definitions, two identities for tangent already here, right? We've got tangent is opposite over adjacent. We have tangent is sine over cosine. We also know tangent is the slope of the hypotenuse, but that one doesn't come into play really at all in this section. Okay, so I don't care about it right now. I have the reciprocal identities. The reciprocals are what 1 over sine of theta is cosecant of theta, dot, 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 right? All of them, yes? So, yeah. So 1 over cotan of theta is tan of theta, right? Go ahead. Ryan, what's up?
No, say it.
I need my odd even identity, odd and evens. Right? I know that sine and tangent are odd. I know that cosine is even. So sine of theta is the opposite of sine of negative theta. Tan of theta is the opposite of tan of negative theta. And cos of theta is the cos of negative theta. Those are my even and odd identities. And then I need my Pythagoreans. So I'm going to go to a new page for my Pythagoreans. So these are kind of new to us. You might know them already. But there's 9 of them, and I'm going to memorize only one. Okay. There's 9 of them, but I'm going to memorize only one. So the one I want to memorize is sine squared of theta plus cos squared of theta equals 1. And this one is obvious. What I want to think of is the unit circle, right? With my radius of 1. And of course I have a height of y, a base of x. And by Pythagorean theorem, I know that x squared plus y squared is 1. Right? So by the way, that's the equation of a circle. I don't think I'm going to get to the conics this semester. So you coming into my Calc 1 class next semester, over the winter, review the conic sections in your pre-cal book, right? They're also in the calc book. So when you get your calc book, and you'll be using the same calc book for Calc 1 and Calc 2. When you get your calc book, review all of the pre-cal. Chapter 1 is pre-cal, and there's a couple of parts of pre-cal and algebra and trig in the appendix as well at the end of the book. Okay, so review all of that stuff. And if you're coming into my class, please look at the conic sections. Okay. So it's obvious, right? X squared plus y squared is 1. And of course, we know cosine is really an x, sine is really a y, so sine squared plus cos squared is 1, right? So from this particular identity, that's the only one I'm going to memorize. I'm going to generate 2 others. So notice that there's 3 terms here. There's a sine squared term, there's a cos squared term, and there's a 1. This is already solved for 1, so I'm going to also solve it for sine squared and solve it for cos squared. If I solve it for sine squared, I'm going to move the cos squared to the other side. I get 1 minus cos squared. And if I solve for cos squared, I'm going to move the sine squared to the other side. I get 1 minus sine squared. So there's my first set of 3 out of 9 of the Pythagorean identities that I want to know. And again, only memorizing one of them. And the other 2 are easy to get. So what I'm going to do is derive another identity from here, and then I'm going to get from that one, I'm going to get 2 others, so 3 more, and I'm going to do that twice. So I'm going to start with sine squared theta plus cos squared theta equals 1, and I'm going to divide that, each term, by cos squared theta. And so what do I get here? I get tan squared theta plus 1 equals, what's 1 over cosine? Good, secant. Very good, class. So I get tan squared theta plus 1 equals secant squared theta. Again, I have 3 terms here. Solve for secant squared right now. I'm also going to solve it for tan squared. So I get a secant squared theta minus 1. And I'm going to solve for 1, and I get a secant squared theta minus tan squared theta. So there's 6 of 9 of my Pythagorean identities. How are we doing?
Headache.
Yeah, I believe you. Take your aspirin. Take your Tylenol. Aspirin's for no. Tylenol's for a headache. The other stuff is for anti-inflammatory. What's the other stuff? Forget what it's called. Acetaminophen? I don't remember. Doesn't matter. Deal with your own damn headaches. All right, I had to start again from sine squared theta plus cos squared theta equals 1, but now I'm going to divide everything by sine squared theta. And I get 1 plus cotangent squared theta equals cosecant squared theta. And from there I'm going to get 2 others, right? So I get cotangent squared theta is cosecant squared theta minus 1, or I get 1 equals cosecant squared theta minus cotangent squared theta. And there it is. There's my 9 trig Pythagorean identities. Only had to memorize 1, and I derived the rest, right? I started somewhere and got something, almost like I'm deriving. Okay, I think we have everything we need here to start doing proving these trig identities. Okay? And so, let me see, let me cheat on this. I don't feel like writing it. I'll just let you write it. Here's my little list. So I'm going to be proving 7.4, proving tree identities. And the whole idea is that I got kind of a process. Okay. Now, I'm teaching you how to play notes. Okay. I'm teaching you how to play a scale. Do, re, mi, fa, sol, la, ti, do. Right? So I'm going to teach you how to play the notes. Eventually, you'll play them very well. And eventually, you can forget the rules and play whatever the hell you want. And so hopefully we get there pretty quick. But kind of step one is kind of putting training wheels on. Step two is a typical process. And then step three are the notes and where I'm eventually allowed to improvise. Okay. So I want to change every term on the more complicated side of the problem into sines and cosines. So for example, if I had a tangent of theta, right? I could write that as sine over cosine. And so now I've got everything in terms of sines and cosines. I'm just going to use S over C. S for sine, C for cosine. Because I don't want to keep writing sine of theta over cos of theta, especially if it's like 7 to 10 lines long of work. I'm just too lazy to do that. Eventually you won't have to do this. You're going to be able to work on identities without having to change things into sines and cosines. But not yet. You gotta do that first. We're gonna work on one side only, and this is kind of a stupid rule of this game, but it's fine. Usually when we have an equation, we can move something from one side to the other, or add something to both sides, or cross multiply. And in this game, we don't want to do any of those things. We want to work on one side as if that's all we had. And typically you'll work on the more complicated side. So no crossing over, right? Until and then you're trying to get the two sides to match. If you get stuck on one side, you can start working on the other side. And that's fine. So you can work on the left side and get it all the way down to match the right side. You could work on the right side, get it all the way down to match on the left side. Or you could work on the left side, get stuck, work on the right side until it matches. Right? Vice versa. Okay? Am I giving you enough time to write all of this down? Make sure you're writing this down, right? You want to be able to look back on it in your notes as you're doing problems. And then here comes our improv part. We're going to try the following depending on what happens. If you have more than one fraction, common denominators. If you can factor, try and factor. If you see a 1 plus or minus a trig squared, that's usually a Pythagorean. And if you see 1 plus or minus a trig, you're probably going to use a conjugate. And I kind of just gave a little examples here. If you see 1 minus a trig squared, you could factor it, right? If you see a 1 plus or minus a trig squared, it could be a Pythagorean identity. And if you see a 1 plus or minus a trig, you're probably using a conjugate. So you see I get the conjugate of 1 minus sine. That's 1 plus sine over 1 plus sine. I remember I have to multiply by 1. And then I get 1 plus sine over 1 minus sine squared. That's a Pythagorean. And then it simplifies to something like that. And I've got a dot, dot, dot there saying there could be more things. I doubt it right now, but there could be more things. So maybe I go back and amend that list a little bit as we start doing some problems. Okay, ready to go? Here we go. That's it. No more teaching. We just get to play now. We get to do some problems. They're fun. And I've done so many of these in my life. When I was in school, I did them all, right? And then every year I teach, I do them all. So 30 years of doing these things, you get pretty good at them. And so you want to try and do as many as you can to get to the tricky ones, that ones you get stuck on and have no clue what to do, right? And then ask for help. Okay, can I start doing problems? Does anybody need another moment on this page? So I'm quitting sugar, I told you, right? So I drink water with lemon. Oh, that's all I drink now. Oh my God, does it suck? I mean, it's delicious, but I'm no more diet soda. Nothing. No. What have I also had? Vitamin water. Third question.
What does the first one say? I can't really figure it.
In blue?
Yeah.
It says change every term on the more complicated side to sines and cosines.
Got it.
Okay. Yep. Does anybody, and let me know, do you need more time on this page before I start doing problems? You think you have problems. Get it? You have more problems in a math book? My girlfriend has more problems in a math book. One of them is me. And the next one is me, she said. And then the next one is me. What? Yes, a lemon vitamin water, please. Well, a couple. Fine. That's the other thing I'm drinking is water with lemon and lemonade flavored. Who knows what's in that? I don't want to read that one. It's supposed to be sugar free. Okay, here we go. We're ready? Let's see, and I'll write each of these down. This is number 39. So these are all coming from 7.4. So I'm not going to keep writing the section number. It's all from 7.4. Does anybody want to see that page again in the book? Take a quick picture of it. We're talking, I'm starting here at number 39. I really like 39 to 93. I'm going to pull problems from there for your tests. There's no homework for 7.4. It's all coming from this page. So do every problem. Okay, number 39 here. It says the secant of theta minus the tangent of theta equals cos of theta all over 1 plus sine of theta. Not that easy to decide which side is more complicated. So on this one, I'll probably do both sides. I'll start on the right. I got a c over 1 plus s. Right? You with me? Change everything into sines and cosines, and then write them as instead of writing cosine of theta, write c. Instead of writing sine of theta, write s. It makes it a lot less work. From my list, I see a 1 plus a trig. That's a conjugate. So I'm gonna take my problem and multiply by the conjugate over the conjugate. 1 minus sine over itself. And you say, how am I supposed to know to do that? I've given you the hints. Look for 1 plus or minus a trig for conjugates. 1 plus or minus a trig squared for Pythagoreans. You'll notice when I do the left-hand side, you'll see what's going to happen is I'm going to get an LCD. But I'm going to keep going here. So what do I get? I get a c times a 1 minus s over 1 minus s squared. And that's a trig. That's a Pythagorean, I mean. 1 minus sine squared, I've already taught you today, as cosine squared. And I can cancel one of those cosines, right? So I get 1 minus s over c. Oh, there's one, divide and conquer. There's one of those tick, tick, dot, dot, dot things I can do. If I have multi-term over a single term, I can divide and conquer. So I get 1 minus c over s minus c. And I can already see that that is a secant minus a tangent. Done. Just trying to get the two sides to match. Add that little divide and conquer to part 3. I had part 3, dot, 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 divide and conquer. What does that mean? A plus B over C becomes A over C plus B over C. Why don't we do that same problem again, but work on the left-hand side, right? So secant of theta minus tangent of theta should turn out to be cos of theta over 1 plus sine of theta. On your mark, set, go. So someone tell me, what does the left-hand side become?
One over cos.
Nice. Yeah, 1 over cos minus
Sine over cosine.
sine over cosine. Nice. And what's up? Oh, sweet. When did you get that? In Jersey. And so now I have 1 minus sine all over cos, and I'm going back to conjugate. So it's not much different. And 1 minus sine squared is cos squared. It's okay. What's up? And so one of my cosines will cancel. And there it is. Cos over 1 plus sine. Done. So it's nice. If you can't decide which side is more complicated, just pick one or do them both. Right? And you'll see, sometimes you'll get stuck and then you'll have to work on the other one anyway. There's times when you'll get stuck on one side and then so start on the other until they match up again, right? Nice. We ready for another? Easy, right? Am I right? Am I right? Am I wrong? Nice.
Right.
Thank you. I like to be right. Let's do 45. And I think I did different ones in the other class, so you can always look at the other video. I've got 1 plus the tangent of theta over 1 minus tan of theta. So it already looks like a conjugate on that side. And the other side I have cotangent of theta plus 1 over cotangent of theta minus 1. And usually, sometimes when you really get stuck, and it just doesn't seem like anything is working, you may have written the problem down wrong. So double check that part for sure. Let me double check here. Number 45, 1 plus tangent of theta over all over 1 minus tan of theta equals cotangent of theta plus 1 all over cotangent of theta minus 1. I don't know. What do you think? Which side? Anybody have a choice? The preference?
The left.
Sure, I like the left. So 1 plus sine over cosine over 1 minus sine over cosine. Nice. Fractions within fractions. When I have fractions within fractions, I want to clear fractions. Uh-oh. Step 3, try this. Dot, 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 clear fractions. Right? When you have fractions within fractions, clear fractions. We already know how to do this. What's our interior LCD?
Cosine.
Cosine. So cosine over cosine is my power, my multiple of 1 that will help me to clear fractions. And here, of course, I'll get cosine plus sine over cosine minus sine. I can already see how to get cotangents and how to get my 1s to cancel, how to get my sines to cancel. But I'm going to pretend I'm stuck here. Okay, I'm going to pretend I'm stuck, and now I want to work on. I want to take all of this, right? I want to work on my other side. I'm going to pretend I'm stuck. Okay, and start working on the other side. What do I have? I have cosine over sine plus 1 over cosine over sine minus 1. And I'm going to clear fractions with sine over sine. And I get cos plus sine over cos minus sine. Done. Haha. I worked on the left side. I got stuck. I started working on the right side. They matched. I'm finished. Done. Approved. All right. I'm going to give you another one, and I'm going to try and shut up. Go ahead, Cindy.
Sorry, I have a question.
Yes.
So sometimes, like, a problem would be the answer to one side won't necessarily like equal the other side. Like you have to do the right side too.
Exactly, and that's part of that's a fair rule of the game. You don't have to get the final answer to be what was there. You just have to get the two sides to match.
Right.
So sometimes you can do it working all the way down the left. Sometimes you could do it working all the way down the left. Sometimes you'll get stuck on one side, then work on the other, and just get them to match. And then we call them proved. We say it's true. Let's see. Let's do. Let's do 59. No, let's do 57. Sorry. Cos of theta all over 1 minus tan of theta plus sine of theta all over 1 minus cotan of theta should be equal to sine of theta plus cos of theta. I definitely don't want to start on the right-hand side because I have no idea what to do, right? I just get sine plus cosine. I don't know what to do on the right-hand side there. I mean, I can do a conjugate there. That's probably, if I had to try something, I could do a conjugate. So I said 1 plus or minus cos is a conjugate. It could even be a plus b, where a minus b is conjugate. So try this. Dot, 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 a plus b times a minus b over a minus b, right? Conjugates, right? Any kind of conjugate. I remember going in college, the teacher going, well, what should we do? And I said, conjugate on with it? Yelling from the back row. Okay, work on the left-hand side. I'll be right back. Anyone get there?
Is it 1 plus sine and 1 minus cos for the tan or no?
So did we start with S?
Left.
Well, yeah, did we start with C over 1 minus S over C? And S over 1 minus C over S.
Oh, I did it 2 parentheses. My bad.
Yeah, so that's where I'm starting. I mean, you don't have to do what I do, but then I'm going to clear fractions. Oh, look at that. I get nice. I got to get you can see I can get an LCD here, right? So I get cos squared over C minus S minus sine squared over C minus S. So now I have something over C minus S. And then I can factor C plus S times C minus S all over C minus S. And these cancel, and I'm done. There's more than one way to skin a cat, but I'm telling you it's easier to start with a dead cat. So you can do anything you want, but I'm telling you switching to sines and cosines will help you get there, right? And then look at my list. What can I do? What can I try? Right? I don't know if we need to do any more. It's Friday. I'm burnt out. You're burnt out. Are you burnt out as much as I'm burnt out?
Burnt.
Yeah.
Burnt. Yes. Okay, good. Let's quit now. So how